Welcome to lesson 64. We're going to talk about semicircles. So this, obviously, is a circle. And this is half of a circle. Half of a circle is called a semicircle. And the way you solve area and circumference for a semicircle is to take the formulas you already know and divide them by 2. So for instance, if you want to get the circumference of a semicircle, I'm just going to get rid of this little line right here because it's confusing. If you want to get the circumference from here halfway around a circle, which would be a semicircle, you would take the circumference formula, which is 2 pi r, right? And then you would divide it in half by 2. So what happens is 2 divided by 2 becomes 1. They cancel each other out. So for a semicircle, circumference is equal to pi times the radius. For the area, that's circumference, for the area of a circle, we have pi r squared. But for a semicircle, because it's half of a circle, you would divide that by 2. And that would be your formula for the area of a semicircle. And I like to just kind of draw the shape around whatever it is. So that would be my idealized sketch of a semicircle. It just makes it a lot faster and easier than writing it out. But if you're not a great artist, it's okay. You can just write area of a semicircle. Same difference, right? And then reference that. Write it so you know what it is. That's the most important thing. So let's do some problems that include the area of a semicircle. Let me clear this and I'm going to draw a shape for you. All right, so here is our first shape. We're going to do 64, example 64.1. So we have what looks to be some weird kind of shape here with a rounded corner. Not corner, but a rounded end. So the first thing we need to do is break this up into shapes that we know we can calculate. So when you have a sloping end like this, the first thing you want to do is kind of break this into a triangle. And we're going to do a perpendicular line so that this is a right angle so that these can be square, right? We'll call this area 1, we'll call this area 2, and we'll call this area 3. Because it's already kind of broken off right here for us. So we have to think about the dimensions of this shape here. We have 10 here and 15 here. We can see that this line kind of cuts it here and this line kind of cuts it here. And that tells me that if this is 10, then this is 10. And if from here to here is 15, then this is probably 5. So I can cross this dimension out. I don't need it anymore, right? Oh, I keep hitting the button over here. So what we need to do is figure out how to get all the dimensions we need for this first shape. We've got the 5 on the bottom, but we need a dimension here on the side. So let's look at something that we know is comparable. This is the hypotenuse, or the slanty side of a triangle. That's what it's called, of a right triangle. But we also have the diameter of this half circle right here. Well, if the radius is 5, then this is going to be 5, because from the center to the edge is a radius, and from the center to the other edge is a radius. So 5 and 5 is going to make this 10, right? So this is going to be 10, because it's straight across parallel lines. So we have a triangle for the first area. So area 1 is going to be the base times the height. Because it's a triangle, it's divided by 2. So the base is 5, and this is in meters. So it's going to be 5 meters times 10 meters divided by 2. Oh, that's not what I wanted. I just want the number 2. There we go. So 5 times 10 is 50. Divided by 2 is 25. So it's 25, and I have meters once, meters twice. So that's meters squared. All right, so now let's talk about area 2. So we have 10 across this way, and we've already discussed we have 10 this direction. So it's just a square, right? So 10 meters times 10 meters is going to equal 100, and meters once, meters twice, or meters squared. All right, so that's area 1 and area 2. Let's find area 3. Area 3 is a semicircle or a half circle. So the area of a semicircle formula, or area of a circle, is pi times r squared, but it's a semicircle, so we're dividing that by 2. So that would be pi times, and the radius is 5 meters. So it'll be 5 meters, and it's squared, so that's times 5 meters over 2. So that would be 25 meters squared. So 25 times pi over 2 meters squared. So when we calculate that, we get, and I hate to use decimals, but we're going to, we get 12.5 pi meters squared. So in algebra, this is the way we would write that. We would add these two together because they are the same variable on the end. And we call the unit of measure the variable, right? That's our base. So this would be 125 plus 12.5 times pi meters squared. We put the thing that they have in common on the outside, and all three of them have meters squared. This is the way we write this answer in algebra. This is what I want to see you start to learn how to do. This is the most exact answer you can give me because pi is a non-terminating decimal. So you can't possibly calculate this accurately with 3.14. However, some of you are going to do it anyway. Start wrapping your head around the idea of using irrational symbols for these numbers. This is the most correct answer there is. Just because you can stick 3.14 in there and multiply does not make it right. Leave it like that. Okay? That's what I want. All right, now let's look at circumference. Now I want to get the circumference for the entire shape. So let's look at the different sides. So we have 10 plus, we have 11.18 plus 5 plus 10, and then we have the semicircle, half the circumference of a circle. So we add all these together, and that's going to be 25 plus this. It's going to be 36.18 for all of this. And the length is meters, so we'll leave that just like that for now. Now let's calculate this bit right here. So the circumference of a semicircle is 2 times pi times the radius divided by 2 because it's only half of a circle. These two cancel each other out, which leaves pi times the radius. So that's going to equal 5, because that's the radius, times pi meters. So we would actually want to write this as 36.18 plus 5 pi meters. That is the most exact answer that you can give me. This is what I want to see. Okay? Do not calculate it by the 3.14. That is not the best answer you can give. Will it work? Yeah, you could throw that in there. You could say 5 times 3.14 and then add it to this. That would be okay. It would be a math equivalent, but it's not exact. Do this for me. All right, let's look at another shape. All right. All right, so for this shape, first we're going to find A, the perimeter, and B, the area. So for A, the perimeter, we've got to find some missing dimensions. So what can we do about this end right here? Well, we could look across, and we could say, oh, well, the radius is 5, then this is 5, plus the other radius, the diameter is going to be 10. So this is going to be 10. So now we look for this side, we look across, and we say, oh, well, this radius is 4, and this is 4, so that's going to be 8. And then we have a section that's 6, 8, and 6 is going to be 14 right here. All right, 4 plus 4 plus 6 is 14. So now we can start to add our perimeter together. So for A, for the perimeter, we would say we have 10, we have 14, and we have 6. And that's in our flat sides that we can just give a length for. So that's going to be 10 plus 20 is equal to 30. And these are in centimeters, by the way. So centimeters. So we have 30 centimeters, but now we have 2 semicircles to find the circumference for. So let's do the first one. We know that the circumference of a half circle is going to be, I don't know if I like that symbol. Circumference of a circle divided by 2, maybe? Nah. That looks like a formula, CO2 or something. Let's just do the circumference of a half circle like that, all right? We know that it is pi r, because it would be 2 pi r, but it's a half circle divided by 2, so we just eliminate the 2's, right? 2 pi r divided by 2 just becomes pi r. So pi r, so that's going to be 4 pi centimeters. And then the other one, the circumference of, this is the 4 radius, the 5 radius half circle is going to be 5 pi centimeters. So let's add these two together. Let's add all of them together. So we have 30 centimeters plus 4 pi plus 5 pi. We have 2 that are exactly alike here that have the same bases, so we can put them together. So we have 30 plus 9 pi centimeters for our circumference. So that's what the perimeter is. It's 30 plus 9 pi centimeters. All right, let's find the area. Let's find B. So we have the dimension. We'll call this area 1. Let's call this area 2. Let's call this area 3. So we have the dimension for area 1. That's 10 times 14. and that's centimeters. That's going to be 140 centimeters once, twice, so that's squared. Area 2, we know that the formula for area of a circle is pi r squared, but it's a half circle, so we're going to divide it by 2. So we're going to say pi. For area 2, that's a radius of 4. So 4 centimeters times 4 centimeters divided by 2. 4 times 4 is 16 pi. 16 divided by 2 is 8. So it's going to be 8 pi centimeters once, twice. So that's 2 right here. Area 3, same formula. Pi, only our radius is 5 centimeters. Divided by 2. 25 divided by 2 is going to be 12.5 pi centimeters square. So now we can add all these together. 8 and 12, these have the same base because they have the same variables. That's going to be 20.5. So 140 plus 20.5 pi centimeters squared would be your answer. Most exact answer you can give. So this is going to equal 140 plus 20.5 pi centimeters squared. All right. If you have questions about these types of shapes, please message me and let me know, and I will help you out with them as much as possible. If you decide to multiply 3.14 as pi in these answers, you can, and the system may or may not take them. Because if I don't have the answer in the book spelled out as to what that is, which the book doesn't give me that, then I have to calculate it and type it in there. And if I am trying to get a lot of work done, a lot of pods made all at one time, I may not take the time to stop and do that. But this is the answer I do have, and it is the one in the book. So it is the one that's going to get typed in first. And then we'll see about the other. But this is the better answer anyway. This one is more right. It's much more exact and correct. So use it. Do not calculate pi. Just leave it. Save yourself the trouble. I'm just asking you to think about it in a different way and to kind of change that mentality of having to get the exact answer, multiply it out to a definite length out of your head. You don't have to. The only time that you need to multiply by pi is if you are going to be using that number physically yourself, like you're buying fabric or you're buying flooring, or you are actually going to do it. Otherwise, leave it in the abstract, leave the pi symbol there, and it's a better answer. All right, I'll see you in lesson 65.